So yeah, Tab Preisel here, assistant professor at Purdue University. So I was kind of leading and facilitating our discussion on composition at the South Pole or South Polar region of the moon. Our documentarian was Jennifer Witten. The names that she was given for our note takers are there as well, but these people weren't in our session, so I don't know if we had other people that were taking notes. And maybe there was a mix-up or something. Regardless, thank you to anyone that was taking notes, and we may call upon you during the next stage of this. And then just a huge shout out to Jenny, um, who powered through it and constructed all these slides for us. So sort of a quick discussion of our summary is we had one lightning talk, which I'll present on a little more detail on the next slide, but essentially Cameron Moye at Washington University in St. Louis was showing work leading towards kind of this a map of the likelihood of whether or not SPA ejected material is present at a given landing site. And they presented some data using the Artemis 3 candidate sites as kind of a case study, so to speak. So that was really exciting. And then that lightning talk generated some discussion, obviously related to the composition of SPA basin ejecta, which really got us off and running to our figures of merit. So in context of the composition of SPA basin ejecta, obviously we identified several sort of major chemical or mineralogical signatures that are going to be really important toward addressing outstanding and Decatur level science objectives related to either the ejecta of that South Pole basin forming impact and or the impact melt generated during the impact process, both of which are going to have this record of the target material, which will be some clue as to the composition or lithology of the crustal material there. And also, as we saw during our presentations, given the size and energy associated with the SPA, certainly some clues and window into the interior and mantle composition of the moon. We did talk again or a little bit more about Lunar Prospector and GRS data and the need for sub-resolution analyses. And the example given was for Mars Gale Crater, where they saw, these water signatures essentially from the, I guess, low spatial resolution data, on the order of 1 weight% or something. Whereas the, high resolution data and surface analyses revealed that there were smaller regions and small sites that had an order of magnitude increased concentration, upwards of 10 or 12%. And so this is just something to obviously take in mind as we carry through and forward and define science objectives and goals. We also talked about kind of on this same thread. Careful attention is going to be really important and needed when assessing and leveraging high latitude spectroscopic data sets in the visible near infrared, and also combinations of LOLA, albedo, and Kaguya data. And so focusing as best as we can on sun-facing slopes or highly reflective regions to further inform either the mineralogical or geochemical signatures anticipated in said region. And then also, we talked a little bit about the thermal neutrons reflecting potentially the presence of rare earth element signatures, and then the complications of that in identifying very well, or as best as we can, the iron concentration or water, which are also going to be neutron absorbers, potentially impacting our analysis of those sites for rare earth elements. And so, yeah, the lightning talk by Cameron Moy from WashU. The figure on the right there is a kind of a key finding of the study, which on the y-axis there shows this SPA material fraction from that ejected material. And then on the x-axis is just histograms of several candidate landing regions from Artemis 3. So you can see kind of based on Artemis 3 landing sites, we're ranging from anywhere from 15 to around 30% probability or material fraction of SPA ejected material there. And so this is obviously a good way for us to very quickly identify regions that are going to give us a higher probability of sampling or analyzing and studying SPA ejecta, which is then obviously going to be tying back to our models of crustal and mantle stratigraphy and moon formation scenarios. And so modeling the Lunar Prospector GRS data to determine the amount of those materials is going to be really important throughout the Artemis exploration zone. And so we're also expecting SPA ejecta to have been deposited across the South Pole and then reworked by all of these later larger impacts, which are, concentrating material towards the center, also pushing it out towards the rim as well of the original SPA impact. And so really kind of going with as high fidelity as we can, tracking and tracing the distribution of that ejected material is going to be super important. Cameron also presented sort of like a linear mixing model to sort of essentially estimate the contributions of the ejected material, the ejected material and its contributions or its makeup of feldspathic highland material and also mantle material. And so we can use some of these, unmixing models to estimate then those contributions of the original target pre-SPA basin forming event. In general, it looked like each region has a reasonable level of ejected material, so there's a good likelihood that we're going to be able to study this at SPA, which is clearly focus of Artemis campaign. That higher resolution data is going to be really important for our site-specific determinations, which we'll get into here. Here's just a list of our participants, and I'm going to kind of cruise through this, just to move on and have more time to talk about our figures of merit. So the first one we kind of talked about, we had two major ones, geochemistry and then mineralogy, and then geochemistry kind of got broken up into several different metrics. And so on the mineralogy metric, we kind of combined several different observations of the distribution and or presence of orthopyroxene, clinopyroxene, olivine as potential mantle material, and then also spinel. And so the reason, all of these are important, we can talk about, maybe a little later. I'll try to summarize quickly here. Orthopyroxene, obviously, potential indicator of deeper crustal and or mantle material. This is by a SPA study from Malash et al. In 2017. Olivine, obviously, could also be associated with mantle material, or if, depending on the outcrop and scale of that olivine exposure, maybe it's also related to olivine-rich magmatism or layered mafic intrusions that have been exposed in that area. And then similarly, spinel has been used as sort of a marker or proxy for the distribution of Mg sweet magmatism. And so if Mg sweet is sort of this initial stage of volcanism on the moon, we're going to be able to be in a location that is potentially excavating material, all of primary magma ocean products and also the initial stages of magmatism on the moon, which is going to put really tight constraints on the timeline of moon differentiation, especially when paired with the geochronology stuff that Amy was just presenting. And so, again, we're focusing on sun-facing or flattish slopes to get as best data as we can from any of our spectroscopic data sets. And then we're going to be, needing all the data resolution on all sides is going to be showing up here. Oops. There we go. So the next metrics was thorium and then kind of a correlation of potassium abundance. And then some of our goals associated with this, basically, SPA is thought to be enriched in thorium, especially relative to the surrounding feldspathic highland terrains. And then whether or not we can use thorium as a tracer for that ejecta material, and whether or not that's linked to creep or late stage magma ocean cumulates. And then also, are there ways we can sort of assess the vertical and lateral gradient and or abundance of thorium throughout the South Polar region there? And again, this is just assuming that potentially thorium is related to creep. Are there, we have a discussion, is there a way to decouple thorium from creep? Is that such a great proxy or not? And these are just kind of like broad sort of foundational or transformational questions that I think we're going to be able to step back and really ask that Artemis 4 is going to enable us to assess and really scrutinize lunar science in a very grand way. So thorium mapped by Lunar Prospector, how does that vary across the potential landing sites? And this can be paired obviously with Artemis 3 and subsequent Artemis missions and exploration efforts there. We also wanted to think about iron concentration. This is obviously important for SPA-derived material, as was presented from Dan's talk and even in some of Jeff Andrews-Hanna's talk as well. And then so the goal here, identifying materials that could be dated to essentially determine the age of that impact event. And so, oh, 1 second, sorry about that. Okay, sorry about that. Kind of forget where I was at. Essentially, we're looking at iron, available data for the iron through our GRS data, visible near-infrared spectroscopy. This is also going to be related to mineralogy components, all of these geochemistry components, and then thinking about, again, kind of this clearly SPA, what's shown there on the example figure, this profile of iron concentration in the SPA relative to the neighboring feldspathic highlands, and that we do have this increased concentration of exposed materials that is revealing some record of the ejecta material. We did talk about ilmenite abundance. This can be tough when pairing that iron concentration data to titanium, which would be a ilmenite iron titanium oxide. But there are, cases and regions throughout the South Polar region where we do see this correlation between thorium and candidate ilmenite-rich regions. And again, are these related then to the late-stage cumulates of the magma ocean? Did the SPA impact reveal that record of our simplified stratigraphy of the differentiation of the moon, exposing late-stage materials at the upper echelon of that mantle, or I guess the moon stratigraphy? Our assessment is that there's going to be, special attention again given to our UV vis near IR titanium, because that does get tough when you get to these low concentrations, which we are going to be dealing with in several potential or candidate locations throughout the South Polar region, and also these high sun angles. In thinking about the rare earth elements, again, this is kind of similar to thorium and potassium, which given a simplified Bowen's reaction series, are all getting concentrated in the residual components during crystal liquid fractionation or differentiation. And so, but these are another marker or a metric for evaluating SPA ejected material related to some of those late stage magma ocean cumulates or other products that have experienced extensive degrees similar to the moon differentiation event of crystal liquid fractionation. And so here we do have to make some assumptions of iron content to essentially remove some of those strong absorbers from other data sets. We did talk about the size distribution of space weathering particles, and this was kind of maybe a smaller topic, but nevertheless still very important to add to the scientific value of all the compositional information we could get from sampling or analyzing materials in situ. This was related to the presence and production of nanophase particles in samples from the moon and meteorites, which could be related to solar wind and also, sorry, where's the small one? Anyhow, this is out of my wheelhouse. Sorry, but we would like to sample the regolith and take a look at these sorts of things and associate them with the quote unquote swirls that may be and have been observed, I guess, present in the South Polar region or SPA. Lastly, we did talk about hematite concentration. This may be brought up in the non-SPA science section, but this is essentially an observation. And so we were thinking about how does space weathering impact different lithologies across the South Polar region of the moon. And so this can, again, be tied back to measurements and analyses from the other Artemis missions. And that is it.
Excellent. Thank you so much, Tab. We'll give some time for questions if people have them. Raise your hand so we can get to you. And while you're raising your hand, Tab, I did have a question on your mineralogy. You had a couple different minerals there, olivine, CPX, OPX. Would you want those all combined into like a mafic index, or are you really thinking those are answering distinct questions and you'd want to have them be separate?
Yeah, if there's other on the call, I'd like to hear their opinion. My opinion is definitely to separate them individually. I think they each have their own sort of potential for revealing context clues, where olivine and OPX could specifically be associated with mantle components. The spinel spectra could be is not predicted in our models of magma ocean differentiation, and is more associated with our secondary magmatic and volcanic products that were also operative during that time of moon history. And then the CPX component would be again potentially associated with late stage mantle cumulates, but also impact melt differentiation, especially if that impact melt did incorporate a large fraction of the calcium and aluminum rich feldspathic crust.
Yeah, makes sense. I get it.